So this is going to be a review of Minesweeper, which was our weekend homework assignment. And as I said, it's usually a good challenging one. So take that for what it's worth. As I said during stand-up this morning, it's a good one because it's kind of applying everything. This is the first assignment that really combines pretty much everything we're going to do on the front end. There's a couple more things we're going to learn in terms of React bits, but this really integrates all of the core elements. So if you feel like it was a brain buster, it kind of is. So let's review real quickly. Let's keep the Minesweeper API open because we're going to need that. It's Minesweeper API Heroku app. So we're going to need the API open because we're going to be referring to this quite a bit. Then let's look at two things. Let's look at the HTML and CSS that we have, and let's see if we can work out our algorithm for how we're going to work on Minesweeper. So hopefully you started out your Minesweeper by rendering your game board. You didn't have to render it like mine. Anything that represents something that looks like a Minesweeper, right? At least 8x8 grid of mines in the beginning would be fine. Anything that looks like a board would be fine. This is my design, so it's in a big table. So the entire rendering is in a big table. In the body of my table, I have a single row for this header. And I get it to span the entire area by using the call span attribute of a TD. So this table definition element, I'm telling it to span 8 columns. If I did not have this call span, this would look like this, right? It would just be one column. So if you want something to span multiple columns, you can use the call span. There's also a row span. So there's call span and row span. So I'm just using call span to have this particular cell stretch out across 8. Whatever you styled it with is fine. If you used an H1 outside of the table, cool, right? There's nothing particular to how I chose to style this that is right or wrong. All right, so I've got a drop-down button in here for easy, intermediate, and expert because maybe we'll get to that as part of what we're doing, but the Explorer mode just said work on an 8x8. I have another row in here for some information to the user. Hey, start a new game. Then I have 8 rows of 8 cells. That's kind of the main board here. And then at the very bottom of this is another row with another cell that's spanning 8 with 10 mines left. So this is what our board that we're going to make today will end up looking like. I just put this straight into app.js. Not worrying about components or any of that yet. I just want to have these cells. So one thing that I will tend to do is keep some text file around of to-dos or my algorithm. For me, I'm going to keep this in the README file. Let's talk about what we need this app to do, what the flow of the application is going to be, how we want this to work. How many of you did that, wrote it out in long, detailed instructions of how Minesweeper was going to work? Cool. Yeah. That really kind of is the key to working your way through this and linking this back to the style that we're learning in terms of building a React app. So I still encourage you to spend time writing out instructions, even if you don't think they get as detailed as they need to be. Any amount of pre-writing you do for attacking the problem will be good.
Kevin, is that something that eventually goes away? Like, do you write out instructions?
I write them out in my head.
Okay.
I look at Minesweeper, I look at this, and I can now do it in my head saying, I'm gonna need an 8x8 grid of something, I'm gonna need a drop down. When that drop down changes, I need to track its state. There's gonna be a button that when I click that, like I can now, for something the size of Minesweeper, I can generate that list in my head when I sit down and look at it. I might sit here and study it for a couple minutes and go, okay, I've got it, and I keep it in my head. For things that are larger where I feel like I can't keep it in my head, my process is drawing pictures on the whiteboard. I will draw pictures and flow in the whiteboard, and then I will take a picture of what's on the whiteboard, and then we'll keep that JPEG file open on my computer as I'm working on the app, right? So I still do this, kind of a PDAC style thing, but I have now adapted it to my working style after having done this professionally for 25 years, right? So yes, I still do it, I just do it in my head. And what I'm gonna try and do now is say out loud and write down what would be in my head if I were looking at this problem. So when I look at this, right, nothing can start in the game until we have a new game. Right, so what happens when we start a new game? Right, it should happen when the user, when they click the new game button. What do we need to do? Well, if I had studied the API, we would have seen that there's a new game API. So use the new game API to request a new game. And maybe I take a note here that it's like post games. That's going to be the part of the API that I need. So I will try and also collect little breadcrumbs along the way of what part of the API am I going to need for different parts of this, so I can know which part to go back and refer to. So we know that the API returns something. So let's take what the API gives back. Let's put that in the state somehow. It's probably a start to a new game. Let's also have it display the number of the game we're playing. Right? So we're playing game 1, we're playing game 2, so forth and so on. So after we have a new game, right, we need to draw the board. Somehow we've got to draw the board. This is going to be an 8x8 grid of TR and TD elements. We know that it comes from the state. The API calls this board. We know that we're going to draw an 8x8 TR and TDs because that's what we created our mockup in. And we know that if we look at the Minesweeper API, it calls this board.
No, I'm following you.
So for each element in the board, put the appropriate character in the table. Right, so whatever cell on the board says it's a flag or a star or what, we're going to put that spot in the table. I don't know how we're going to do these things yet, but that's generally the written description of what this needs to be. We're going to render these bits out. Right, so that will handle making a new game and drawing something on the board. What are the two aspects of the game? What are the two things the user can do besides starting a new game?
Left click and right click.
Yeah, so we can flag a cell. We can, let's call it check a cell and flag a cell. So when the user checks a cell, what do we need to do? We need to tell the API that the user checked a cell. What are the things we need to tell it? Well, let's look at what the API says. The API says that when we check a cell, we need to give it three things. We need to tell it the ID, or the number of the game, the row, and the column. And they're called exactly this. Right? We need to give it the ID, the row, and the column. And this looks like post. What's going on? This looks like post to games ID check. And to flag a cell, we need to tell the API that the user flagged a cell. We need to tell it, well, lo and behold, it's the same thing. We need to tell these things, and that is post games ID flag. We tell the API that a user checked the cell. We need to tell it these things. Right? That's us looking at the user interface, thinking about what the user is doing, looking at the API. What is the corresponding thing we need to ask the API to do? So when we looked at this last week, we said, hey, look at the API response for check. It looks like the same data that we had when we created a new game. And if we look at the API response for flag, that looks like the same kind of thing. Right? So we need to do the same thing here. Take what the API gives us back. Take what the API gives back and put that in the state. And the same thing here. Right. Whatever checking a cell gives us, we're going to put that back in the state. Whatever the flagging gives us back, we're going to put that back in the state. Right. Kind of like how in cryptocurrency, or if you worked with the JSON or the API for Octocats, you took whatever the API gave you and you stored that in the state. Right. We now know that this is going to render based on the state. Right. Actually, we kind of say this up here. Right. We're going to render the board based on the state. So there's a couple other things we could do inside of here. Right. We could handle a game over in some special way. Display something to the user. Right. We could handle easy, intermediate, difficult, whatever was it called? Oh, expert. Easy, intermediate, and expert. Right. But maybe these become our stretch goals towards the bottom. This is probably enough to get us started. Right? If we run into something that gets us confused, we come back to this and keep drilling down in more detail. So let's do the next step, where we kind of make up some fake data. Let's take a look at what this says the data is. So in these cells, we can have an empty space, an underscore, a flag, a bomb, a flag cell with a bomb, or some numbers. So let's put some numbers in here, just so we can see what our user interface looks like. 2, 3, 4, 5, 6, 7, 8. Let's put a 2 here and a 3 here and a 1 here and a 7 here, and this is all made up numbers. All right, but if we reload this, okay, cool. We see some data. And maybe inside of this one, let's do flags and bombs. 3, 4, 5, 6, 7, 8. Flags and some bombs. And this looks like a little bit of a Minesweeper board, right? We're still working with static data. We're still just working with some examples. Right? We haven't done anything with state or the API yet, just static stuff. How many of y'all did this part? Did I get to this part? Cool. All right. So if we have this where we're drawing these from static data, let's try having this come from an example state. We said that in our README, we're eventually going to pull something back from the API and store it in a state. Let's make up a fake state. And we can do this a couple of different ways. We could make a state right inside of here. Let's make a fake state right inside of here. Let's make a new constructor. This is pretty much how every one of your constructors is going to start. Constructor props and super props. And you're going to make some kind of state. Let's call the state variable we're going to keep our game. We'll just call it game. You could have called it whatever. Doesn't matter. This part here is Taco Tuesday. You can call this whatever you like. You are controlling which part you're calling this in. You could have made the entire state, the entire object, the entire game, but generally it's a good idea not to have the entire state be the response that comes back from your API, because you want to be able to have other things in here. So eventually, if we're going to store maybe like a high score, or the time that the game took, or how many games you've played, you're going to want to put that in some other state. So it's generally a good idea not to use the entire state as the API data, but tuck it inside of an attribute inside of state. So this is a pretty common pattern as well. Let's go grab from our API what a new game looks like. Right? This is what a new game looks like when we create it. So we're going to make that this game state. We're just going to grab an example game and make that our game state. Here's our board. We said that our board, right, is going to come from the state, right, and the API calls this the board. So let's keep this board on the screen and look at these cells again. Right? Let's replace the hard-coded we just typed right into each TD. Let's replace that with something that comes from this state. Right? We don't want this to be 023178832. We type these in. We want these to come from the state. So we want this to be dynamic. If this is my state, how do I get to my board? What's the next thing? This dot state dot game. Yeah, board. But if I want the very first, if I want this row, the one that's got the 0, 2, 3, if my board is what kind of variable? What is board? It's not a number, it's an array. Right? ID is a number, state is a string, mines is a number, board is an array. And we know it because there's that square bracket. So I want the first element in this board array that is index 0. Now if I want the first element in that array, that is element 0. Right. The second one is going to be still the 0th board array, but index 1. And I can repeat this for 2, 3, 4, 5, 6, 7. We can get rid of these. Right. So this becomes 1, 2, 3, 4, 5, 6, and 7. Now if I put something in this board, let's put a bomb there, let's put a 2 there, and let's put a flag here. Okay. As I change this state, that row changes, right? If I can change the state, the row changes. So let's repeat that now for all of these. Let's repeat this now. How do I get rid of this? Let's repeat this row 7 more times. 1, 2, 3, 4, 5, 6, 7. So this is no longer the 0th row of board. Which should I put here? 1. And then 2. Oops. 2. And then this gets 3. This gets 4. This gets 5. This gets 6. And then this gets 7.
Are you doing that all with keys?
What's that?
The highlight straight down? Are you doing that with keys only?
Yes.
Are you?
In your version, it's Control Shift down, I think. Selection. Yeah. Control Shift down. Yeah. If you're replacing a word, you can just hit Command D. So like if I wanted to replace all the instances of board, you could highlight this board and then like Command D, Shift D. Oops. Go away. Hide that. Go away. Stop popping up more windows. There we go. Right. I think it's Command D will select. Once you've selected like this word board, you know, see how it's kind of lit up the rest of them.
Mm-hmm.
Nope. What is it? Selection. Oh, add next occurrence, Command D. Right, so then it's selecting the next board. Right. So if I've replaced all these now with just their position, as I put things into this board, they update. So we kind of have this done. Right, and we kind of have this done. Make this an X. Actually, just do it done. Done, done, and done. Right? We're drawing the board. But we left something off. Let's have it update the number of mines remaining. We missed that. So that's kind of way down here. 10 mines left. Let's update that based on the board, based on the state. So not a hard-coded 10, but what?
The stuff state
Yeah, this state game mines. This state game mines left. So 10 mines left. If we change this now to a 7, it should say that there are 7 mines left. Okay. So mines left. So let me add this and commit it. Drawing of the board based on the state. So in case you just want to copy that app.js, you're free to copy that from what's on GitHub or in the repository. Okay. All we're doing so far is just drawing the board based on the state. Whatever state we give it, that's what the board's going to draw. Okay. So far, so good. So let's go back to new game. When the user clicks the new game button, you use the new game API to request a new game, take what the API gives you back, blah, blah, blah. So if the first thing that's going to happen is click the new game button, let's take this as a new game button. Let's add an on click. Let's call it new game. And then let's make a new game event. New game is a function that takes an event and is going to do a thing. I like to make sure that it's doing what I want it to do, so I'm going to add a little debugging. This should make a new game. I'm just going to confirm that when I click on this button, I get a new game. So let's go to console. And if I click on this, cool. All right, checking my work along the way. So I said what this should do is use the game API to request a new game. So here's where I need to use the API for the first time. Right. I need to post to this URL. So let's add the Axios library to our app, because we want to use that. It's going to be easier than using fetch. And then we wait. Well, that's,
I'm sorry. Should we always hub create? Should we always use hub create when we start a new app?
Yeah, for create React app, if you want
React.
there to be a Git repository that goes along with it, yes. I'm not doing that because I'm making this part of your shared repository. If I were making an independent repository, yes, I would do hub create, because that's a step that app used to do for you that create React does not. Cool. So we've got our Axios library. Let's import it. So import Axios from Axios is how we get that library loaded into our component. Now let's use it. Axios post to the URL. HES Minesweeper API Heroku app.com/games. Then we get a response back from the API. We're going to do something. Let's console log the response. Let's just console log what did the API give back to see if we can understand what that response is. Nope, not saving the game, saving my code. Oh, and I need to restart yarn. So we added a library. Yarn can't find it. Let's restart yarn. So it will reload a lot of things, but it's not reloading the extra modules that we added. So we'll restart yarn. Yeah, see, it said it could not find Axios. If you do the Control-C thing to stop yarn start and then add Axios and then restart yarn, you won't have this problem. Wait. Is it starting? Any questions so far? Does this kind of match a little bit of what you all were working on? Did you follow this kind of path? Let's see what happens now when we press the new game button. Hey, we finally got back this response object. This response object comes from Axios. This is all of Axios's information, but tucked into that is this data. That kind of looks like Mines 10, board ID. That's our stuff. Right? The data that comes back, response.data, is what the API is giving us back. This here is response.data from Axios. Response.data. So if we just console log response data instead, that should kind of look like our API results. Let's start a new game. Hey, right? That kind of looks like our state. Doesn't that look like our game? Right? What we copied has an ID and a mines and a state and a board. So if this is our response, this set state, let's make the game the response data. We're handling the new game button. We're requested a new game by posting this. And we're taking what the API gives us back, and we're putting that into the state. When we click on a new game, we're asking the API to start a new game, and we're taking what comes back, and we're putting it into our state. We said that where we keep it in our state is going to be this thing called game. So what I hope to see is when I click on this, I hope to see this board change and the number of mines reset to 10. Right? Because a new game should have an empty board and 10 mines. Right? New game starts, 10 mines left. Cool. So we also said we wanted to show the game number. We'd like to put this here. Actually, let me commit this.
Kevin, could you elaborate on how the mines change back to 10?
Yeah. So when we had the game initialized, our this.state.game set the mines to 7, right here, 7 mines. When we ask for a new game, we're taking what the API is giving us back, and we're replacing all of this. Whatever was in our kind of dummy initial state, we're replacing all of that with what this gives us back, and it's going to give us back 10 mines. So this will go away when we say this.setState game becomes the response data. We're taking what the API gives us, which is this, and we're slapping it on top of replacing what game is. We're replacing this.state.game with whatever the API gave us back. Right? So if it told us 100 mines, that mines would become 100.
I didn't set up the mine counter. Did you go back down to where you set that up?
Yeah, so down here, where there's mines left, we just said this state game mines. Exactly how many mines are in that state, that's what we're going to display on the display. Cool. So we wanted to show what the current game number is. Right. So let's put it here where it says start a new game. So we want this start a new game to say this when there isn't a new game, and we want this to say the game number when there is a game playing. So let's remove this junk that we put in here, right? All these fake bombs and flags and whatnot, and reset this. And we'll put the mines back to 10, right? No reason to have it still be 7. But we want some way to know if we're playing a game or not playing a game, right? We have this state here, right? We say the state is new when the game is new, and it's new here, and the game is playing down here, right? So we have a couple choices. We could make this ID 0 to say, hey, this is our fake board. And we could make this a 0. And we could change the state to a state that the game itself is not using. We can make up one called like waiting. And either of those as a way to say that there's no game playing would work. The other thing we could do is make another state called playing. We could make that false. So do you see why it's important to have not the entire state be the API response? Because it would block us from be doing something like tracking our own state. Let's do this one, where playing is false. So here's what we want to do. We want this start a new game to say one thing while we're waiting for the user to play a new game and something else when they are playing a game. Let's start by pulling this string into a function. And let's call this header text. So header text is just going to return start a new game. I'm going to put like three exclamation marks in there just so I know that it's working. So this is what I want this header text to say. So let's replace this hard-coded text with calling header text. Right? So instead of just hard-coding that header text, we'll call a function that returns it. Start a new game, exclamation mark. But we want this to be if this.state.game.playing is what? Is false. We want to return that. If the state of the game playing is false, that's what we made it up here. Not game. This.state.playing, my bad. This state playing, not part of the game, because the game is what the API is going to give us. Our state, this.state.playing is false. We want this to be that. And then if it's not that, if this state playing all of a sudden becomes true, right? We want it to return something like, you are playing game number, this.state. Where's the game number stored? Game, you said it, I think you said it, Frank.
ID.
State ID, yeah. Sorry. I heard it coming, this state, game, ID. Right? So if the game is not playing, we'll say start a new game, but if the game is playing, we'll say game ID.
So, what would happen if you didn't do any of this? If you,
Then it would just say start a new game the entire time.
I see.
Right? I had that hard coded into this text. It would just say start a new game the entire time we were playing. But one of the things we said we were going to do is display the number of the game we're playing. That was one of the requirements that I set forth when I laid out my instructions.
But you could do an if else statement.
Yep, yeah, absolutely. Good point. We're totally going to get there. But nothing is changing this playing state. So why don't we, when we make a new game, also change playing to true? So we'll change two things. We'll make the game what comes back from the API, and we'll change playing to true. So now when I start a new game, you are playing game number 17750. So to Frank's point, yes, absolutely. Let's use an if-else statement. So if this state playing we're going to return this one. Right? If we are playing, let's do this, else, let's return this. Oop, one too many braces. We can get rid of all of these lines here. If the state is playing, then let's have that header text show you are playing this, otherwise start a new game. Right? Let's do something similar for the number of mines down here. Right? We don't want to show the number of mines there are before we play a game. We want this to be blank before we start a game, and then show the number of mines when we are playing. So let's make a little function for that. Let's call that mines text. So mines text is going to be similar. It's going to say if this.state.playing, let's return 10 mines left. We're going to replace this with a dynamic data. Otherwise, let's do this. So if the playing state is true, we'll say the number of mines. Otherwise, we'll return blank. But we want this to be dynamic. So let's turn this into a dynamic string and say this.state.games mines. Right? If we're playing,
How's no it's true right there?
because that's what an if statement does. It says if this thing in parentheses is true, then this, otherwise that. So what kind of variable is my playing? I got you, Kenny. I'll come to you in a second. It's a Boolean. So if this is the same as doing, never write that. It's useless. Because it's the same as saying if playing. You never have to say equals 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 true. If you ever write equals 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 true, just get rid of the equals 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 true. Right? Because that's what an if statement does. If what you give me is true, I'll do the first thing, otherwise I'll do the second thing. That's why it works in header text as well. If playing is true, then do this. Kenny, you had a question?
Yeah, you use the dollar sign because it's in a string.
Yes, because I'm interpolating a string. Now down here, where I had the mines, let's just call mines text. So now this should be blank until I start a new game. Oops. What's my mistake? Does anybody see my error? Saying I cannot read property mines. What's that?
Game.
Oh, yes. Game, not games. This.state.game mines, because this.state.games would be undefined. Cool. Thank you. Hey, let's tighten up this text. Let's just have this say game number. That's too long of a text. I don't like the wrapping. Start a new game, and we click. There's our game. So we're done with this. And we also are done with this. Anybody cool so far? Questions? Right? Notice what I haven't done yet is I haven't pulled out any cells or anything for any of this board stuff. Right? I'm not looping anything yet. This is still kind of hard coded, right? But a number of the things in the game are working. So this app.js is updated if you feel like copying and pasting along, if you just want to catch up to where we are. So if you pull app.js from GitHub, that's there. All right, so we can start a new game and we can draw the board and we can update the mines. All right, we've got a game number. We're going to check cell. All right. The next things next are to deal with, right, clicking and right-clicking on cells. If we're going to do that, it's time to extract a component, right? That component's going to have some behavior. Let's pull that component out and start to write a cell component. So let's, let me get my Explorer back. Let's make a new component. Let's call it cell. Let's use our handy dandy autocompleter. The cell is just going to be our TD. Right? Our cell just represents one of these little cells. Right? Our cell component that we made. Right? And maybe let's just stick a 9 in it for now. Let's hard code it and worry about how we're going to deal with it later. So instead of this TD, let's just replace it with a cell. If I did the autocomplete right, no. I have to import cell from cell. And I'll show you what I tend to like to do is just kind of organize these a little bit. All of the library things in one group, my CSS in another group, and then my components in a third group. You'll find different people organize these things differently. Hey, look, there's a 9 on the display. Why is there a 9 on the display? Well, because the cell has hard-coded what it's going to display inside. I always start from something hard-coded, and I pick a weird value so I know that what I'm getting there is my cell, but it's the hard-coded version of the cell. I don't want the cell just to render a 9. I want it to render the value to show inside of that. So let's pass the value in this way. I'm just going to pick another random value. Let's have it show a 5. Right? I'm still hard-coding. Tiny steps. I don't want this to show a hard-coded 9. I want it to now show the hard-coded 5 that comes in from my parent. So if a component is passed something, how do I get access to it? This dot props. Right? And the property is what I decided to call it, which is value. That's a Taco Tuesday. I can call that prop whatever I want. Hey, now it's showing a 5. But it's not really a 5, is it? Wait, before we were doing this dot state dot game dot board 0 0. Right? And it should go back to a space, right? Because that's what was in this board. let's confirm that. If we come back up here to our board and we replace this with a bomb, do we get a bomb? We do. So it's still rendering from the board. So if that's the case, then we can repeat all of this again. 1, 2, 3, 4, 5, 6, 7. Whoa! I touched the mouse. 1, 2, 3, 4, 5, 6, 7, 8. Right. And if that's true for this one, then we can replace all of these. Just going to delete all of these rows. One, 2, 3, 4, 5, 6, 7. Ah! I keep doing that. I'm ending up like my hand touches the mouse pad, and then it moves the mouse, and then I paste. 1, 2, 3, 4, 5, 6, 7, 8. Cool. Let's go back and redo that tedious work of changing these all back to ones. Yeah, I think it's just because like the way that I rest my wrists on, I have this bad tendency of resting my wrist on the mouse pad, not on the other part. I just have to train my wrist not to sit there, and I'll be okay.
Yeah, the newer Macs made the mouse pad wider.
Yeah, and my brain is still trained with the size of my old mouse pad. So let's put all these back now to using a component. So now hopefully we should have all of these as a component. And if I pick randomly one of these cells and make it an F, does an F show up in that spot on the board? It does. So I've replaced all these with components. Let's make it so we can click on the cell. Let's call this method flag cell. Flag cell is going to be a function that takes an event because it's handling a click. Let's just console log something that we clicked. Let's start a new game. Hey, we clicked. All right, now I can click on cells. Notice what I haven't done here yet. What haven't I done with all of this?
Still static.
Yeah, I haven't done any kind of mapping yet. Right, that's going to be hard. I'm going to put the hard stuff off to the almost the last thing that I do. Nothing is making me yet need to change this. Nothing so far is making me have to map these. If I never do anything but easy mode, there's no reason to map these. The only reason I would have to map these is if I want my code to be smaller, or if I wanted to handle a board that wasn't an 8x8. I want to put that off as long as I can, because the mapping of this is probably going to be challenging. So here's the part where we're going to tell the API the user needs to check a cell. But I think this is a good spot to take a break. What we have so far is a dynamic board, the ability to start a new game. We can display the number of the game we're playing. We can display the number of mines that are left. And we know that if we were to update the state in our app, that our board would change. So when we come back from break, we'll figure out how do we, inside of this flag cell, tell the API that we clicked on we checked a particular cell and caused the board to update. Right? We're gonna have to add some things to our app to do that, but that's where we're gonna work from. So it is 10:25. Let's come back at 10:35. Let's just take a 10-minute break. So come back at like 10:35 and we'll continue working on checking.